Hi everyone, welcome to my YouTube channel. I hope you all are doing well. So today in this video, we are going to solve the problem is graph bipartite. So first of all, we'll be going through the problem statement, then the logic part, and then the coding part. Before proceeding further, make sure to subscribe the channel if you haven't done so. It will really motivate me to create more such content for you, and you can follow me on other platforms as well. The link is there in the description. So do check them out. Well, let's get started with the problem statement now. So the problem says there is an undirected graph with n nodes where each node is numbered between 0 and n minus 1. You are given a 2D array graph where graph U is an array of nodes that node U is adjacent to. More formally, for each V in graph U, there is an undirected edge between node U and node V. The graph has the following properties. There are no self edges. Graph U does not contain U. Okay. There are no parallel edges. Graph U does not contain duplicate values. Also, if V is in graph U, then U is in graph V because the graph is undirected. So if U is pointing to if V is in graph U, then U is also in graph V. Okay, that makes sense because the graph is undirected. The graph may not be connected, meaning there may be two nodes U and V such that there is no path between them. Okay, so now comes the question. So there's too much theory guys. Now comes the question. Some of you must not be even sure like what exactly a bipartite graph is. So here they have explained about it. A graph is bipartite if the nodes can be partitioned into two independent sets A and B such that every edge in the graph connects a node in set A and a node in set B. Return true if and only if it is bipartite. So what does it actually mean? So let's say we are having this graph. Let's have a look on the example one. So first of all, here in the input, what do we have? We have 1, 2, 3, 0, 2. So see, this is the 0th index, right? So at 0th index, what is the neighbors? What is the neighbors? So you can see 0 is pointing to 1, 2, 3. That's what they do mean by this. Then at first index, so 1 is connected to 0 and 2. Then at second index, so 2 is connected to 0, 1 and 3, and then this is the third index, so 3 is connected to 0 and 2. Okay, so how we can say that this graph is a bipartite graph? We can say this is a bipartite graph only if when we can divide, we can partition the nodes that we do have in this graph. So here we have 0, 1, 2, 3. So we can partition these nodes in such a way in two independent sets such that there should not be any edge between the nodes which are in the same group, but the edge should be there between the nodes which are in different groups. So let's say one node is in set A and one node is in set B. So there is an edge, there is a link. Okay, that's what they have specified here. For example, let's say what we are doing here is this graph itself we are taking. Okay, and this 0 we are starting. You can start from any like we can choose any random node. So let's say I'm starting with this 0. Okay, I've started with the 0. Then 0, I have kept this in set A. Okay, I'm keeping this 0 in set A. Then what is the neighbor of this 0? This node 0, 1, 2, 3. So what I have to make sure that, see, I don't want the edge between the nodes in the same group. So there is an edge between 1, 2, 3, like they are connected with 0. So I cannot keep 1, 2, 3 in set A if I have kept the 0 in set A, right? So I'll be keeping them 1, 2, 3 in set B. Okay. But again, this will create a problem. Let's say how. So 1, if let's say we came to 1. So the 0 is visited. This is done. Okay. 1. Now with 1, so you can see 1 is connected with 0, right? And to 2. But okay, 0 is fine because this is in set A, but 2 is in set B itself, and it has already been, like we have already seen this one. How we have seen this one? Because it was a neighbor of 0 also. That's why we kept this in set B. So in that case, what we can determine, what we can conclude, that this is not a bipartite graph, or that's what even they have explained, that there is no way to partition the nodes into two independent sets such that every edge connects a node in one and a node in the other. Okay, so this example also we'll be understanding. Okay, I'll show you on this example. So I hope the problem statement is clear, right? The problem statement is clear. Now, what is the way to solve this particular problem? How we can approach this problem? First of all, when I was explaining this part, right? So I was mentioning that, okay, we'll be checking the neighbors. So either you can go with the BFS or DFS approach. I'll be solving this problem with the BFS approach, right? So one node I have chosen, right? Then I'll be first visiting its neighbors, right? I'll be checking them, right? So let's understand it further, the logic part, and then we'll be having a look on the code part. Okay, so here we are. Let's say this is the graph given to us, right? So 0 index, first index, second index, third index. So 0 is connected with 1 and 3. So here you can see 0 is connected with 1 and 3. Then 1 is connected to 0, 1 is connected to 0 and 2. Then 2 is connected to 1, 1 and 3. Then 3 is connected to 0, 0 and 2. Okay, so that's how it is. Now, as if I mentioned that we'll be solving this with BFS approach, and how we can determine if a graph is bipartite. So if we can partition the nodes of the graph in such a way that the node of one set is having a connection with the node in another set, and in the same set there should be no connection between the nodes. Okay, so I hope that is clear. So what do? We'll start our traversal from here. We'll start from this node, okay, from the 0th node. Okay, so did you remember that coloring technique? What we can do? So let's say what we can do, we'll be using one visited array. Okay, we'll be using one visited array. So let's say I have seen this 0. Okay, so I'll be, or let's remember the color concept. Okay, so I'll be coloring this. Okay, let's call the color name as 1. So I have colored this with 1. So what I have to make sure is that adjacent node or the neighbor of this node should not be colored with the same color, right? So I'll be giving some different color to them. Okay, so first I have chosen this 0 node. Okay, so 0 I have kept in the queue, and visited array I'll be taking. So that be depending on the number of nodes that we have. So initially they all are, everyone is 0 0 0. Now I have seen this one. So what I'll be doing, I'll be marking it as 1. Okay, I'll be marking it as 1. Now what are the neighbors of 0? 1 and 3. So I'll be removing this out, and I'll be putting 1 and 3 in the queue, right? And also 1 and 3 in the queue. And what I'll be doing, I'll be providing them some different color, these neighbors. So what is the color of this one? The parent one, right? So I'll be providing them the color -1 to this one, -1 to this one. So let me mention here as well that 1 as -1, and this 3 also as -1. Okay, next we'll be removing this 1. So 0 we have already visited, right? So we can check about this. We have already visited 0, no issues with that. Then here comes 2. 2 we have not visited, right? 2 we have not visited. So here what we'll be doing, here we'll be providing it the color which is not belonging to the parent. So if it is -1, we can provide it 1, right? We can provide it 1. Okay, so this one we'll be providing the color 1. Okay, and also we have to put this 2 in the queue, right? Then we'll be removing this 3. So okay, 3, this was the 3, right? So with 3 we were having what? 0 and 2. So 0 is visited, 0 is visited, and 2 is also visited, right? And then comes what? Then comes 2. So we'll be removing that 2. With 2 we have 1 and 3. So 1 and 3 is also been visited, right? So now what we can determine is, we can determine that this is a bipartite graph, right? So while we'll be changing these colors of the neighbor nodes, right? Of the neighbor nodes, we can add one condition. If there comes a scenario where the color of the parent node and the neighbor node is same, right? When we were updating this color part, right? 1 -1 we are doing. So if any such scenario comes, so we can determine in that case that this is not a bipartite graph, right? Okay, let me take that example also, where we were having what? Or let me partition this part, right? So let me partition. So this one 0 and 2 we can keep in one group, and this 1 and 3 we can keep in one group, right? So you can see 0 to 1 we have a node, we have an edge. Then 0 to 3 we have an edge. Okay, then 1 to 2 we have an edge, 1 to 2 we have an edge, then 2 to 3 we have an edge, right? So see, in between there is no edges, right? When they are belonging to the same set and different set, there we are having an edge, right? So this is a bipartite graph, right? Likewise, you can do what you can take other example that was given, right? That was given in the problem statement, which is not a bipartite one. So first we are doing, this is our visited array, right? Now just we are going through the elements that we do have in the graph, right? So first what we are checking, that if the ith value, so visited of I, if it is equal to that of 1, or if it is equal to that of -1, it means it has, we have already gone through this. So what we are doing is just we are marking it as like continue, right? Otherwise what we are doing is like we are having a queue and we are adding the ith value. So as of now I value is what, 0, so we are adding this 0 to queue, right? And we are marking this with 1, so visited of I equal to 1. Now what we are doing, we'll be continuing in this while loop till the time queue is not empty. So we are popping out the element that we do have in the queue and we are exploring its neighbors. So as of now, first we'll be having 0. So what are the neighbors? 1, 2 and 3. We'll be exploring them. Now so for each element that we do have in graph current, so graph 0, what is the element that we are having? 1, 2, 3, right? So what we are doing, so as of now in the starting nothing has been visited, right? So 1, 2, 3 has not been visited, so we are marking with them the value negative to the value which is of the current value is what, 1, so -1 will be allotted to 1, 2 and 3, right? So here just after this allotment part, right, we are just making sure, we are just checking that if the visited element value is equal to that of visited current, right? It means if the value is same, so we have to return false. So as of now, for this first case, this condition is not going to be true, right? And also with each part, what we are doing here is like we are adding the element also. We are adding the elements also. So in queue right now, what will be added? 1, 1, 2 and 3. Like these 3 elements would be added in the queue, right? So again, we'll be continuing in this while loop. So queue is not empty, right? So current value we are popping out. So first 1 will be popped out, and again we are exploring what the neighbors of the 1. So what are the neighbors of 1? 0, 0 and 2, right? These are the neighbors of 1. So here what we are doing, we are checking if, see, in this condition we won't be going because 0 is visited and 2 is also been visited, so obviously they are not equal to that of 0. So here we are checking if visited of element, right? So 0 visited of element, let's say first it is 0, so that is 1, and current, that is 1 to 1, what is the value that we assigned? We assigned -1, so this condition is not going to be true. Then the next neighbor is what? 2, right? With 1 we have 0 and 2, right? So 0 we have seen, now 2 comes, so obviously for 2 also this condition is not going to be true, because 2 also we have marked it as -1 because it was a neighbor of 0, right? So visited of LE, so visited of 2 means what is the value of visited of 2? -1, right? So -1 equal to visited of current is 1, so visited of 1 is also -1. So condition is getting true, right? Condition is getting true. Adjacent node here are having the same color, so it means that it is not going to be a bipartite graph, so simply we are returning false from here, right? So I hope that makes sense, I hope that is clear. So right, so see, if any time this condition never became true, so at the end what we are doing is we are simply returning true that it is a bipartite graph. Okay, so that's what it is. I hope you are clear with the problem statement, you are clear with the logic parts. If you are clear with the logic part, I would ask you to implement it by yourself. In case if you are finding any difficulty, then you can refer the code. I have provided the code link even in the description, so you can just check it from there. Thank you so much for watching, everyone. Bye bye.